All right, we are going to talk about today. Our goal is to decode a system's real world situation. So, we've been talking about systems of equations, and now we're going to apply it. How would we use this in the real world? So, I know that word problems can seem pretty intimidating, but we're going to read the problem first and then go back and read it without our numbers, summarize it, and then write our equations. So a group of 42 people go to Fright Night at Six Flags. The admission fee for adults is $16. The admission fee for children is $12. The group spent $568 to get into the park. How many adults and how many children were in the group? Okay, so we know that we are going to have two equations. So let's look at this first question here. What is unknown? Well, we don't know how many adults and how many children. Okay, so the unknown is how many adults and how many children. That's what's being asked. They want us to figure out how many adults went, how many children. All right, so the second thing we're going to do is assign variables to our unknowns. So adults are unknown. We're going to let them be X, or we could let them be A, I guess. Adults can be A, and children can be C. Okay, so the first thing it says is to write an equation to represent the first relationship. So the first relationship is we know that there are 42 people that went. So if I go back and say, okay, 42 is the total number of people. Who makes up the 42? Adults and children. So if I take the number of adults plus the number of children, I should get 42. So our first relationship is A plus C equals 42. The second relationship has to deal with the cost. So if you're an adult, it's $16 to get in. If you're a child, it's $12. So let's attach those prices to our variables. So adults is $16. So 16A, it's $16 for every adult plus $12 for every child. So if I take the total cost of the adult tickets plus the total cost of the kids' tickets, I get the total that the group spent, which was $568. Okay, so that's writing our system. Now we could solve it by graphing. We could solve it by substitution. Let's work on writing another one. A sporting goods store receives a shipment of 124 golf bags. Okay, total golf bags, 124. The shipment includes two types of bags, full size and collapsible. The full-size bags cost $38.50. The collapsible bags cost $22.50. If the shipment total is $3,718, how many golf bags of each type are in the shipment? Let's just work on writing out, answering some of these questions and writing the equation. So what's unknown? Well, what are they asking? How many golf bags of each type? So how many golf bags of each type? Okay. All right, so what are our unknown values? Assign variables to them. So we have two different golf bags. We have full size, we'll let that be F, and we have collapsible, we'll let that be C. So let's write an equation to represent the first relationship. So let's go back and read our problem and find our first relationship. The first relationship says a sporting goods store receives a shipment of 124 golf bags. Okay, there was two types of bags, I had full size and collapsible. The total number, if I add the full size and the collapsible together, I had 124 bags in total. F plus C equals 124. Okay, so now we write the second relationship. The full-size bags were $38.50 each, so $38.50 times F, however many full-size bags, plus $22.50 for my collapsible, for a total amount of $3,718. So again, you can solve this by graphing, substitution, however you want to solve it. I would probably solve it by substitution. I would let F equal 124 minus C and then plug that in. All right. Let's keep working on writing our system. So there are 8 bills in a bag that total $100. Some of the bills are $20 bills and others are $5 bills. How many bills are 20s and how many bills are 5s? So what's the unknown? How many 20s and how many 5s? So we're going to assign variables now to our unknown values. So we'll let 20s equal X and 5s can equal Y. Okay. So let's go ahead and write the equation for the first relationship. There are 8 bills in a bag. Okay, so 8 bills. Well, I have some 20s, which is X, some 5s, okay? But there cannot be more than 8. So X plus Y, 20s plus $5 bills have to equal 8 total bills. Of those, like when the 8 bills are all in there, the total is $100. So I have 20 times X, okay? So the 20X, X represents my $20 bill. So if I have one $20 bill, it's 20 times 1. I have $20, okay? If I have $5 bills, that's going to be 5Y. Okay, so if I have one $5 bill, plug in 1 for Y, $5. Okay, that total is going to be $100. So there you go. That's how you would write out your equation. All right, let's do another one. It takes Kristen 10 minutes to make a black and white drawing and 25 minutes for a colored drawing. On Saturday, she made a total of 9 drawings in 2 hours. How many drawings of each type did Kristen make? So what's unknown is how many black and white drawings and how many color drawings. That's what we don't know. We know she made some of each, but we don't know how many. All right, so now we're going to assign variables. So we'll let black and white equal B, and colored can equal C. So write an equation to represent the first relationship. First relationship is that she made a total of 9 drawings. Okay, so if she adds together her black and white plus her colored, B plus C is going to equal 9. Now, this next one is where we get a little bit tricky. So we know that it takes 10 minutes for a black and white. So that would be 10B, 10 minutes, plus 25 minutes, 25C. And we know that it took her 2 hours to make all of those. However, we cannot just put 2 because everything else, 10 is referring to minutes. 25 is referring to minutes. So we can't change our time there. So we have to now convert hours to minutes. So we know there's 60 minutes in an hour, and we did it for 2 hours. So now we're going to have 120. So that's going to have to equal 120. And again, I would solve this by doing substitution.